Hello my students. In the earlier module we saw the shortcut methods for integrating the type 1 upon a plus b sin x plus c cos x. In this module we will apply the same to some more sums. Let us take the very first example. The question says integral of 1 upon 4 minus 5 cos x dx. First, I would advise you to have a look at these options. It is very important that we keep an idea about these. Now, the shortcut. It said very clearly that we need to multiply the numerator, or to be precise, replace dx by 2 dt. So let us start doing that. In the numerator, instead of dx, now I am supposed to write 2 dt. Then it said very clearly that the constant term is multiplied with 1 plus t square. So I'll have 4 into 1 plus t square. The coefficient of cos is multiplied by 1 minus t square. So I'll have 5 into 1 minus t square. That minus is as it is. Now my dear students, this is our integral which needs to be solved by perfect square method. So let us open the brackets in the denominator. So the numerator remains as it is. In the denominator I will start with 4 plus 4t square, and in the denominator minus 5 plus 5t square. My dear students, we are opening the bracket, outside there is a minus, so therefore please remember it is plus 5t square. Now my dear students, in this case it is 4t square plus 5t square, that is 9t square, and 4 minus 5, that is minus 1. Now since this is entrance, we are supposed to write fast and we are supposed to skip some intermediate steps. So my dear students, in this case 2 dt is there as it is. Instead of writing 9t square minus 1, I will write it as 3t the whole square minus of 1 square. Now we know that this integral is of the form 1 upon x square minus a square, and the formula for the same is 1 upon 2a. So let us apply. The 2 in the numerator is as it is, and a in this case is 1. So I'll have 2 into 1. That I'll keep it as it is now. 2 only. Log mod of x minus a, that is 3t minus 1 upon 3t plus 1 plus c. Now my dear students, you may feel something awkward at the beginning of log. The 2 in the numerator and the 2 in the denominator are not aligned because I am forgetting something. We also need to observe that the coefficient of t in this case is 3, so we need to divide by 3. Is that okay? Now my dear students, this is my final answer. So let us simplify and check which option is the correct one. 2 and 2 will cancel to give me 1 by 3. So let me put that 1 by 3 log mod of 3t minus 1 upon 3t plus 1. Now let's check the options. The options are here in front of us. 1 by 3 is present only in two options, A and B. So obviously C and D are not the answer. Minus is present only in option A. So option A is my correct answer. When I said minus is present only in the option A, it meant that minus is present in the numerator in option A, which is what we have in the answer also. And that's how we solve this sum using the shortcut. Let's apply this shortcut to one more sum. Let's take that. Now in this case, I have integral of dx upon 2 plus cos x minus sin x. Now my dear students, again if you see in the denominator, I have the constant term, I have a cosine term, and I have a sine term as well. So let us apply the shortcut. For your reference, again I will bring the shortcut. Now the shortcut says replace the numerator by 2 dt. The constant will be multiplied by 1 plus t square. The cosine term, coefficient of cosine will be multiplied by 1 minus t square. In this case, coefficient of cosine is 1, or I can say in this case, replace the cosine term by 1 minus t square. Replace the sine term by 2t, so minus of 2t. Now our job is to open the brackets. What we'll get is 2t square minus of t square, which is t square. I have a minus 2t, and if I open the brackets, I have 2 plus 1, that is 3. So what we will get in the next step is 2 in the numerator, or to be precise 2 dt, and in the denominator is t square minus 2t plus 3. Now in the next step, 2 kept as it is, t square minus 2t plus 3. My dear students, it is fairly easy. T square minus 2t plus 1 can be written as t minus 1 the whole square. Now if I am doing a plus 1, I will have to do a minus 1. 3 minus 1 is root 2, so I should have a plus root 2 the whole square. Pardon me, 3 minus 1 is 2, and therefore I can say in this case 2 will be written as root 2 the whole square. Now what are we supposed to do? Write the formula for this. The integral we have is in the form of 1 upon x square plus a square, and the formula for that is 1 by a tan inverse of x by a. So let us apply 1 by a. My dear students, there is already a 2 in the numerator. So in this case, we will write 2 into 1 upon root 2. So can I say that 2 into 1 upon root 2 will be as it is tan inverse of x by a. So can I say t minus 1 upon root 2, and a plus e has to follow. Now my dear students, these are the options in front of us. You can know, or you already are clear, that 2 upon root 2 is nothing but root of 2. And root of 2 is present only in two options, A and B. So it's very clear C and D are not the answers. Now, the final answer has tan inverse of t minus 1. So minus should be present in the answer. In option A, you find a plus. So you know option A is also not the answer. So that leaves us with only one answer, which is option B. So the correct answer in this case is nothing but option B. And this is how we are supposed to tackle the sums which are based on tan x by 2 equal to t. And this is what I have in this module for you, my dear students. Thank you very much.